Question 1 of the review assignment for the second test on chapters 3 and 4 in Math 1060 Trigonometry. Number 1, use the even odd identities to verify the identity sine pi minus 12 theta equals negative sine 12 theta minus pi. Let's go ahead and start with the left-hand side. Sine pi minus 12 theta. Then because I have my end goal in mind with the pi and the 12 theta switched, I'm going to go ahead and switch them. So sine negative 12 theta plus pi. Well, now notice my goal, this is positive, not negative, and this is negative, not positive. So let's go ahead and factor out that negative. So the sine of negative 12 theta, factor a negative out of a positive and we get a negative. Now here's where we use the odd even identities. Since sine is odd, the sign of a negative value is the same as the negative sign of the value. So that negative just goes to the front because it's an odd function. If it were an even function, we could just get rid of that negative completely. That's what would happen if it were a cosine. That leaves us with 12 theta, what happened to my pen? 12 theta minus pi. And look, we've got our answer. Number 2, use the sum and difference identities to find the exact value of the tangent of 105. You may have need of the quotient, reciprocal, or even odd identities as well. Okay, let's start by figuring out what angles we can use to create 105. So tangent of 105, the first things that came to mind for me were 60 and 45. I'm sure there are other possibilities. You could probably even do a difference somehow. Now, I don't have this formula memorized as well as I should. So let's see if I can remember it. I think it's 1 minus tangent. Oh dear, I'm not remembering off the top of my head. Here, I've got it right here. It's tangent of alpha. I'm just going to write it over here. Tangent alpha plus tangent beta over 1 minus tangent alpha times tangent beta. Okay, so we get tangent 60 plus tangent 45 divided by 1 minus tangent 60 tangent 45. Well, let's go ahead and simplify that. So the tangent of 60 is square root of 3, and the tangent of 45 is 1. So then we have 1 minus tangent of 60, which is square root of 3, times the tangent of 45, which is 1. So I'm not even going to write the 1 because timesing by 1 doesn't change anything. So there's one way to leave your answer. This one, however, is much better looking if we rationalize it. So let's go ahead and work on rationalizing it. We're going to do that by multiplying the conjugate of the denominator. So the conjugate of the denominator, 1 minus square root of 3, would be 1 plus square root of 3. Now we're going to multiply this out, our two binomials. So we have to do the distributive property with our first outside, inside, last. Some people call that FOIL. So first we have square root of 3 times 1. And then we have square root of 3 times square root of 3, which is square root of 9. I'm just going to write that as 3. Square root of 9 is 3. And then 1 times 1, which is 1. And then 1 times the square root of 3, which gives us another square root of 3. So that simplifies to 2 square root 3 plus 4 in the numerator. The denominator, we have 1 times 1, which is 1. 1 times square root of 3, negative square root of 3 times 1, and then negative square root of 3 times square root of 3, which would be negative square root of 9, or minus 3. So these two cancel out, and 1 minus 3 leaves us with negative 2. So now we can reduce this by the negative 2. I'm going to go ahead and factor, just so you kind of see exactly what I'm doing. Square root of 3 plus 2. I just factored a 2 out of the numerator. And I have this negative 2 in the denominator. I'm just going to move the negative out front instead. If that's okay with you. Move my equal sign a little bit. So then I get 2 reduces into 2, and we're left with a negative square root of 3 plus 2. I'm going to distribute that negative through both of these terms. And our final answer is negative square root of 3 minus 2.